Hello everyone, good evening and welcome back to the third day of the Arduino and robotics workshop. Okay, so this is actually today is the third day and the last day of this Arduino and robotics workshop. So today we are going to talk about the some advanced robotics or with some different sensors. And let me just recall you all that on the day one we studied about the basic components. First of all, we started with the definition of robotics. How do we separate any machines in general with the robotics? Okay, and then we discussed about what robotics are and what are the different components which are required to build any robots in general. Okay, and then we started working with the all the different components which do we need. Okay, for example, we talked about sensors. With then we discussed about the microcontrollers and especially about the Arduino and the applications of Arduinos, and why do we need Arduinos and why Arduinos are used very widely. Okay, and then we basically started working with the outputs also, like LEDs, like motors or actuators, right? So, and on the day one we saw how we can basically program Arduino Uno. Okay, and then there we saw like how we can basically program Arduino in Arduino Uno to control LED. Okay, so we saw how we can basically first of all control a single LED, and then we programmed a RGB LED, which is basically a red, green, and blue LED, which is basically capable to generate any possible colors. Okay, so that what we discussed in the day one of this workshop, and in the day two we discussed about the basics of the sensors. We started with the sensors. What are the different kinds of sensors available in the market? Like there are two different kinds of sensors, like analog and digital, right? So for digital, we saw how IR sensors work, and how we can extract the data from any IR sensor using on our serial monitor, right? And similarly for the analog sensors, we used LDR, so that how we can get the analog sensor data, and for that we used LDR, which is basically a light dependent resistor whose resistance depends upon the intensity of light. Okay, so today after the sensors, we saw how we can basically build any robot, and then we started with our first robot, which was actually the object follower robot. Okay, and we programmed the object follower robot from scratch on this board. Right, let me just show you this robot. So okay, just give me a second. Okay, yeah. So, and yesterday we basically programmed this particular robot, and we programmed this robot using these two particular IR sensors, right? So these IR sensors are today in the downward direction, but yesterday we placed this on the surface of this acrylic chassis, right? And we programmed this IR sensor with this Arduino on this Curie follower robot kit, right? So we programmed this in such a way that this particular robot was able to follow any object in front of it. And yesterday we also saw the live demonstration of this robot of the that it is basically following any object in front of it, and we can control its direction just by giving the signal by any object by putting in front of this any of these IR sensors, right? And there is actually one more very important component used here, which is actually the motor driver IC. So yesterday we also discussed about this motor driver IC. Like we are in this kit we are using basically L293D, right? So L293D, or there are different motor driver ICs also available in the market, like ULN2803 are some ICs. Okay, so why do we need motor driver IC? So that the current coming from the microcontroller can be amplified, so that the motors can get proper power. Okay, so this was it. We this is all we actually discussed in the last 2 days. And now in the third and the final day and the last day of our robotics with Arduino workshop, we are going to we are going to see how we can basically build our own remote control robot. Okay, and what are the components which we require for that, and then we are going to see about one other robot which is basically a cliff avoidance robot, or you can also say edge avoidance robot. We will see why that cliff avoidance robot is also required, and then we will see the live demonstration of that also. And if we get time, we will see a live demonstration of one another robot, which is basically a Bluetooth controlled robot. And I will try, if we get time. So I will try to show that Bluetooth controlled robot on this particular robot over here, because this one has a Bluetooth module over here, right? So and let's start this from the beginning. Before that, let me just show you that this is basically the RF, the remote of the robot, and the robot I'm having is this one. Okay, so this is the basically remote, and this is the actual robot which we are going to control with this remote. Okay, so there are two sensors, there are two methods through which you can basically control this particular robot. I hope you all can see this, that you can control this robot wirelessly. This is basically the antenna. This robot works properly without the antenna also, but we have interfaced this antenna so that we can control it over a larger distance. Okay, so this is basically the joystick over here, which you all can see. So you can control the direction of our robot by the joystick. There is one another sensor. Basically, this particular sensor over here is called gesture sensor, or technically it is called accelerometer. Okay, so this particular sensor basically detects the tilt, or the the changes in the orientation of this sensor, and it generates any analog value with respect to that. So let us say if my remote is like this, and if I tilt this in the right or the left direction, or in the forward or backward direction, this particular sensor, this gesture sensor or accelerometer sensor, will give us some changes in its x, y, and z coordinates values. Okay, and we can basically yesterday we saw how we can basically extract the data, get the data from any analog sensors, and how we can basically program it according to our design, according to our decisions making logic, to control any robot. So today we are going to see the demonstration how this robot can particularly work with the use of these two sensors. Like first the joystick, and the second one is the accelerometer, which is basically the gesture control. Okay, so let me just turn on my another camera so that initially we can discuss this more in detail, and then we will talk about that. So this is our robot over here. This is my remote, and this is my robot. I hope you all can see this, right? Okay, so let me just explain a little bit about this remote first of all. That there are two sensors like this joystick and this gesture sensor or the accelerometer. These two sensors are basically going to give us the data in terms of analog values, okay, and which can be programmed using this Arduino Nano, which is interfaced over here. All right, and so there are two other things. One thing is basically here the encoder. Okay, so this is basically the encoder over here, which you can see. I hope you all can see. Let me just take this one out for that. This IC over here is basically, this black IC over here is basically an encoder, which encodes the signal which we are getting from joystick, as well as which we are getting from this gesture or the accelerometer. Okay, but what this little red devices, this is basically a remote, this is basically generates a radio frequency signal. Okay, so this over here generates a radio frequency signal of 434 megahertz. Okay, and this radio frequency a signal can be transmitted using this antenna. All right. So the initial work is the first of all what we need to do is we need to uh, we need to get the data from these two sensors like this joystick and from this accelerometer or the gesture. Okay, through this Arduino, and then we are going to send all this data through this antenna wirelessly to this robot. Okay, so if you consider this antenna as transmitter, so consider this antenna as receiver. This red device is basically the transmitter module, and this one over here is basically the receiver module. Okay, here is the receiver module, and here we are using actually 4 DC motors, which are basically bigger than the bow motors which we use traditionally. Okay, so these are the DC motors over here. These are basically the metal DC motors. Okay, the early what we saw yesterday was basically the plastic and the geared motor in the bow shape. Okay, so this is basically the receiver module over here. This PCB. This one, this red one is particularly is the device which receives the radio frequency coming from this transmitter. Okay, this receives this, and then what we need is we need to decode all those encoded data. So for that there is this particular IC over here. Okay, and then again this particular IC is not going to give us that much amount of current to control all these motors. So we are going to need one motor driver IC also. And in this module also we have one L293D module. Okay, so this is basically the circuit of a remote controlled robot. So first of all, let me just show you how we can basically program, how we have basically programmed this robot, and how we can basically get the data from this joystick and from the gesture. Okay, so for that I am going to connect this with the battery we have over here. This is now just the powered up. Okay, so for the representation, I have interfaced 4 LEDs also on this remote. This remote basically looks like a gaming console, right? So here you can see that whenever I will push, whenever I will push this joystick in the forward, backward, left or right direction, different LED combinations are going to turn up. Like this is forward, this is backward, this is right, left, and this one is the right. Okay, so this is basically programmed on this Arduino from the data which we are receiving from this joystick, just like the yesterday what we were doing from the LDR module, LDR. Okay, so this is basically programmed in the same way. It's just a little bit more complicated, but the overall thing is exactly same. Now let us say that if we do not want to control this robot using this joystick. Okay, now let's say that if we want to control this robot using our gesture control. Okay, so what we are going to do is we are basically going to, we only need to just change the mode from this. Now please notice that we do not even need to touch this joystick. These possible LEDs will actually glow just by using this gesture. You can see over there, right? So I'm not basically pressing any button or any switch, neither this joystick. This basically the combination of different LEDs are glowing because it is receiving the data from this gesture control, which is basically accelerometer, and this particular Arduino is detecting the analog values from this sensor, and then it is programmed in such a way that at particular values of X, Y, and Z, these LEDs will glow. Let me just show you this again so that you guys can get a better data. I hope you all can see this, right? Okay, so this is how these things are basically programmed. Now the important thing is, let me just turn this off. Okay, now we are going to, since right now we have just discussed about the working of this robot. So now what we are going to do is we are basically going to test how this robot can basically work on how we can basically control this robot wirelessly through this remote, okay, which we have over here. So let me just get this in one hand, and let me just uh, change the position of my camera so that we can get all the data. Okay. Yeah. So here you can see that this is basically my robot, and this one is the remote which I have. So right now I cannot control it because because my remote is off. So first of all we need to turn this on. So the moment I turn this on, you can see that this particular yellow LED also turns up. I hope you all can see this. Um, yeah, this particular LED, okay, which basically means that this remote and this robot is paired. Okay, if this LED is not turned up, this yellow LED is not high or not on, so this robot cannot be controlled using this remote. So now let me just show you the demonstration how this robot can work. Okay, so now it is going to work on this particular joystick module because I have set it using through this button. Okay, so let me just show you first of all how we can just rotate this robot because my table is not actually that big over here. So when I'm trying to do left or right, I can basically rotate this more precisely. Okay, so right now I'm controlling this using this joystick. Okay, so that we can make it more visible. And if let us say if we want to make it go like in forward or backward direction, since it is very high rpm, the motors are of very high rpm, but still let's try this. Okay, so right now you can see that this robot can basically be programmed. This is a basically a programmable robot because we have Arduino over here. Okay, and you can control this robot using joystick or through gesture over a range of around 500 or at least 400 meters. Okay, so now let's see the demonstration of this accelerometer and how we can basically control this a robot using the gesture only. So now I'm changing this. I'll change the mode. Now I'm not going to press any joystick or any button. I will just tilt this and this robot will work. You can notice. And for forward and backward, I have programmed this in such a way. Okay, so this is how you can basically program this particular robot. Okay, and you can. Okay, let me just turn this off so that it does not move anywhere. Okay, so let me just get back to this camera. Okay, so this is how we can basically program our robot to control it, to manually control it through a larger distance through wirelessly. Okay, so we do not need our robot to be, let us say if you do not want your robot to be autonomous. So for autonomous situation, you are going to need some sensors for that. But let's say if you want to interface, if you want to control your robot manually, so you can basically use a radio frequency system, okay, radio frequency communication module, so that you can basically control your robot through wirelessly over a larger distance. Okay, so there are different modes of communications also available for wireless communications, like the radio frequency, like infrared control, as well as like Bluetooth control, which we will see in like 10 to 15 minutes. And then other thing is like the Wi-Fi control, or there are other modes of control also, like there is a Zigbee protocol or Zigbee modules which you can use for much larger range. Okay, so now what we are going to do is okay, so this is how we can basically control our robot. So now let's see that in this system, in this remote control, let us say that if we want to control our robot on this table with this high RPM motor, so there is going to be a problem, which is basically that that are, if we are not very careful, that this robot can jump off or fall down from the table, right? So for that, that is going to be a problem for any robot, because if it falls down from the table, the hardware as well as the motor chassis and stuff are going to get damaged. Okay, so now for that, what the other robot is, the third robot which you can say, the other robot is that we are going to program this robot in such a way that if this robot using these two sensors, the programs are actually going to be same like yesterday, just a little tweak in the logical execution. Okay, the sensors are going to be the same, the robot is exactly the same. It's just that today we have placed this IR modules, IR sensors in the downward direction, so that it can basically detect the presence of table. Okay, I hope you all can remember this, that this IR sensor basically detects any object in front of it. Okay, and now we want it to detect the presence of table in front of it, so that if it is on the table, it is going to run in the forward direction, and the moment any of the IR sensor detects that there is no table or there is nothing in front of it, first thing it will do is it will stop, it will go back in the backward direction, and then it will take a left or right. Okay, so this is how we are going to program this in this way. Okay, and then we are going to test it out, that if it works properly or not, or if we face any problem for that. So for that, let me just show you the programming Arduino IDE. First of all, that what things we are going to change over there, so that we can program this robot. We can see how the robots are going to be executed, and then we will show you the live demonstration of this robot. Okay, so let me just first of all keep this away, and then we are going to start this thing. Sorry. Yeah, so let me just share my screen of the Arduino IDE of the last day code. Okay, so we are not going to write the whole code from scratch, because we have already done that yesterday. We are just going to see how we can basically change the codes. Okay, yesterday which we were actually which we basically wrote down. Let me just share this code. I have not shared it still. Okay, yeah. Okay, so I hope you all can see this code, right? Okay, so this was the code which we basically wrote yesterday. So now what we are going to do is, first of all, these sensors are same, motor driver IC is same, and the connections are basically same, because we are using the same board. Okay, so what do we need is, we need to change here in the main algorithm or in the main loop function. First of all, we are going to initialize these two IR sensors for sure. Okay, just like the yesterday. Okay, but here the things will change. We have to change a lot. Okay, so first of all, what we are going to do is, first of all, we are going to initialize this, that if there is if both the sensors detect basically high. Okay, so it should go forward, means that if it detects that there is something in front of it, so it should basically go forward. Okay, so for that, what I'm going to do is, I'm going to write down a function. Okay, so I'm going to write down a function forward. We will initialize the functions just in a bit. Okay, that how this basically robot, or how this function basically works. Just give me a moment. Okay. Yeah. So first of all, what we are going to do is, we are going to detect that if there is something in front of it or not, and if there is something in front of it, as I hope you all can recall that yesterday we saw, if there is something in front of it, your IR sensor basically detects low. Okay, so what we are going to do is, if both the IR sensor detects that yes, there is something in front below it. Yeah, okay, so it is going to move forward. What forward is? Forward is basically a function, and we are going to write this forward function in details. Okay, how we are going to execute this forward, backward, and stuff. Okay, so let me just either write this down about the forward function, that basically so that you can get the idea how do we write functions also. Okay, and yeah, one more thing, like functions in programming languages works exactly same like the functions are used to work in mathematics. Okay, whenever you want to call a set of programs or a set of instructions, or in general you can say in programming terms, like whenever you want to repeat a set of lines of code, you can just make it as a function and then you can call it whenever you want. Okay, so we will see how it basically saves a lot of time and as well as a lots of space also, and it makes our code look much more elegant in terms of the earlier version. Okay, so we write the functions like this, that I'm using a void. Okay, so the function I'm going to write down is the forward, and then what we are going to do is we need to initialize or write down all these four lines of the motor drivers. Okay, so what do we need is to move forward, we want it to go like this, right? High low, and so that this our robot can basically move in the forward direction. Okay, now yesterday what we did was we used if statement for the four several statements, right? So now we are not going to need that. There should be only this robot can be programmed only by the two functions. The one should be like the if, and the other one can also be in the if statement, but we can write down in such a way that if a status sensor 1 is low, and we can change this and to the or statement, or operator basically. Okay, so this and or operator basically works in the same way like in the logical gates. Okay, let me just explain this a little bit. Let us say if we have a AND gate or AND operator, so AND gate will generate a high in the output or 1 in the output only and only if all the inputs are high. Okay, so this is basically the AND gate. Okay, so this what this basically means, that if sensor 1, if IR sensor 1 and IR sensor 2, they both detects that yes, there is something beside this, there is something in front of these sensors, then only forward will this forward function will be executed. Okay, and if it detects that only one of the IR sensor is high, okay, which means that only if and if only like even one of the IR sensors detects that yes, there is nothing in front of it, so it is going to execute this line of code. We are just going to change this one. Okay, so what we want is like, let me just change this. So how do we want it? First of all, we want this robot to stop. Okay, we will write the whole code for this. Okay, so we want this code, we want this robot to stop for like 1 second. Yesterday also I mentioned that this delay, the value of this delay function basically operates in the milliseconds and not in seconds. So okay, please do remember that and don't get confused with this. Okay, so we want this robot to stop, and then we want this robot to go in the backward direction, right? For around 1 second or 2 seconds. Let's try with the 1 second. If it will not work properly, so we will increase this delay, and then what we want is we want this to turn left or right, whatever you want. You can basically program this, and let's give a delay of half a second so that it does not rotate completely. Okay, and then it should go forward if it detects that yes, both the IR sensors are getting low, means if both the IR sensors basically detects that something is in front of it. Okay, so now just like the forward code, forward function which we have written, we are going to write the same logic for 4 times basically for the backward. Okay, so what do we need here is uh, we have to write it for the backward. Okay, and yeah, remember that in Arduino the program is basically case sensitive. Okay, so do keep that in mind. Okay, so this should be low, this should be high, it is basically going to be the reverse of forward, right? And that is the only case where you can make your robot go backward. Okay, so and for backward this is done. Now let's say if we want our robot to turn left, or let's say turn right, so I'm writing this for turn left. Okay, so for turn left, what we are going to do is we need this low, and only one high can be is sufficient actually to turn our robot in the left or right direction. Okay, so this is it, and then there is one more function which is basically the stop function, right? So let's write the stop function too. Sorry, yeah, this is the spelling for stop, I guess. Okay, yeah, s is the capital, s is the capital over here, and to stop we will have to give all the values to the low. Okay, all the motors should be low so that we our robot does not move anywhere, right? So this is how we are going to program this. So in this code we saw that how we can basically write functions for everything. For example, if we do not use functions, so we are going to like here you can see that this main logical operation, like this one looks actually very elegant. Okay, and this saves a lot of time, and this makes your code very easy to understand for anyone. Okay, so here you can see that basically, okay, so basically there are two logical command over here, logical operations are going to be executed over here. The first thing is that if both the IR sensor detects that yes, something is in front of it, then it is going to move forward. And the other one is if even any one of the IR sensor detects that there is nothing in front of it, so first of all it is going to stop for a second, then it is going to move backward for a second, and then it is going to take a left for a second. Okay, and then if it detects that yes, something is in front of both the IR sensors, so it is going to give you a high signal, means it is going to move forward. Okay, so now right now I have just connected my board to my computer so that we can basically upload this program. All right, so go to the tools. The procedure is exactly the same like yesterday. Go to the tools, select boards. I am using Arduino Nano, so I have already selected Arduino Nano. The processor is fine and the port is COM8. Okay, so now let's go to the upload code, and let's upload this code over here. Okay, so here you can see that the code has been done uploading, and here you can see done uploading. Okay, so now let's just close this. Let me stop sharing this thing. Okay, and let me just turn on the other camera so that we can basically see how this robot is going to work. But let me first of all connect our robot with the battery. Okay, so just give me a second. Okay. If anyone has any question, so you guys can ask. Feel free to ask any question if you have in the chat section. Okay. Meanwhile, I can connect my robot with the battery which I have. Okay, so let me just turn on my camera on this one. Yeah, I hope you all can see this. So this is the exact robot. Now the IR sensor is in the downward direction. And let me just take the camera in the backward so that this entire table can be visible. Okay. Yeah, a little bit more behind actually. Yeah, I hope. Okay, yes. So this is visible to everyone, right? So now what I'm going to do is I have already. Let me just connect this and let's see. Let's observe how it is going to work. If there is nothing in front of it. First of all, it is going to detect, obviously. It is going to stop, and then it is going to take left turn over here, which you can observe, I guess, right? So yeah, so here you can see it detects that there is nothing in front of it. It stops, it go backwards, and then it takes left for some time. Okay. So by using these kinds of programming tweak or programming changes, you can basically make this robot autonomous in much a larger way, as well as for the industrial applications also. If you are, let's say, a college student, or if you are a school student, so you can basically program this robot in this way, and you can design and create more and more better robots. Okay, so yeah, so let me just get back to this camera. All right. Okay. So you can see. I hope you all have just watched this demonstration. That yeah. So that's how we can basically make our robot much more advanced, and we can basically upgrade our robot in, and we can basically make it more and more autonomous. Okay. Like right now we just saw this robot, how this robot can particularly work if there is an uneven surface, or if you want this robot to move on a particular a table or particular high end surface, right? And this particular robot can also be programmed as a line follower robot also. Okay, and in line follower robot, what happens is basically you will draw a line over there on any surface, on any surface based, in most cases the lines are supposed to be black, so that it can be, I know the color can be differentiated very easily with the sensor. Okay, and IR sensor basically detects the presence of any object in front of it using the infrared radiations, right? The transmitter and the receiver. Okay, so if you use black lines, so IR is not going to detect the presence of that object, because the black lines absorb not just the line, the black colors usually absorbs all the infrared radiation, so it does not reflect any IR light or rays to the receiver. Okay, so that's how you can basically build your own line follower robot using this robotic kit. Okay, so you are this robot kit can help you basically learn more and more programming of robotics, Arduino. Okay, and it will basically upskill your coding skills also. Okay, and you can basically program this robot in these five different sections. All right, so if there is any question about the sensors or the working, or anything in general you want to ask about robotics, feel free to ask or discuss in the chat section. Okay, and since I think we have around 5 to 10 minutes, so let's see this robot also. This robot over here, which is basically a Bluetooth controlled robot. Okay, so just give me 1 minute so that we can basically see this. Okay, we can, let me just connect this through the app. Okay, I will show you the app also. Okay, is basically the app which we have made over here. This is basically our Curie Robotics app, and this app is sufficient enough. This app can basically control our robot, which is here. In the Bluetooth module, this one is the Bluetooth module. Here you can see that this is basically blinking, which means that it can now communicate with any Bluetooth app which we have made. So first of all, as here you can see that there is a show device option. So first of all, I'm going to connect this with our robot. So just yeah, please hold on a second or something. Okay, so that we can basically connect this with our robot. And yeah, so you can see all the Bluetooth devices which with which we can communicate, with which we can basically connect. So I'm going to connect this with the HC05, because this robot is this robot Bluetooth module is basically the HC05. Okay, happened over here is that this motor actually we have damaged the wire of this motor, so this motor over here will not actually work properly. Okay, but yeah, you can basically see the operation over here. Okay, so let me just show you guys with on the other screen. It will not take actually more time. You can just hold it on your hand also. It will not actually recommend. Yeah. Yeah, okay. So this is basically the app which we have, and this is our robot. So here you can see that we can basically control this robot, and as I mentioned that this particular motor, the wire of which is actually connected on this particular motor actually got damaged. So, but still, yeah, we can see that how this basically works. See, I'm controlling this just by using this motor is basically not working because of this thing. So but still you can see that the working of this module is perfectly fine. Okay, and let's say if we just quickly if we change the PCBs on this robot, so this will actually work very nicely. So just give me a moment or something so that we can basically connect this one over on this thing. This is actually very easy because it is designed in this way that you can just uh, plug it in and plug out if you need to disassemble this. So now this is going to work here nicely. Yeah. So we are not going to need this robot because we have made this robot our Bluetooth controlled robot. So now let's just connect this again. Yeah, it is done. Now let's see how it is going to. First of all, let me just take it in my hand so that it does not move very rapidly. Yeah, so now you can see the left, right, and the forward, backward directions all are basically working quite nicely. Okay, so in this way, you can basically program your Bluetooth controlled robot, and you can actually control all other parts also. For example, like this is RGB, this is your buzzer, and in this particular kit, you can let me just turn this off. In this particular kit, you can also program this on the servo motor. Also there is a place for servo motor, and initially we have interfaced the gripper. This one is actually a 3D printed gripper which we have interfaced with the servo motor, and you can also connect a ultrasonic sensor also. Let me just show you this over here is basically let me just yeah, so this over here is basically this sensor, okay, which is over here, I guess. Okay, okay, sorry. Yeah, so this is basically ultrasonic sensor, and this is basically a servo motor, and these two can also connect with this Explorer robot kit. This one kit we call it Explorer robot, and you can basically make this robot more autonomous. Okay, so this ultrasonic sensor also detects the presence of any object in front of it, but this is much more precise, and it can give you the data in analog forms. Okay, so it can not only detect the presence of object, but it can also tell you that how far that particular object is in front of it. Okay, so you can basically rotate this thing like this. Okay, all right, and you can basically map the environment in front of it where your particular robot is moving, and then you can make it a autonomous robot which will not actually collide with any objects, and it can also give you the data on your phone, also on your Bluetooth app. All right, so let me just get back on my main camera. Okay, so I hope you guys have understood the basic concepts, how robotics work, how and why Arduino is one of the most useful and one of the most widely used development boards or controller nowadays. Okay, Arduinos are one of the easiest way to start learning about robotics, start learning on embedded systems or programming any microcontrollers and stuff. And we actually we actually have made the implementation of robotics or the learning of robotics much more simpler. Okay, so that students of beginner stage, students of intermediate stage do not have to worry about the hardware chaos which we get on our breadboard in general cases. But you can basically take our kit, you can basically purchase our kit and start exploring from the second day. Okay, so you can basically design your different kinds of robots, you can test out all those sensors, joystick controllers, and you will get a very clear idea how any machines in general, any embedded machines or any electronic machines in general work. And you can then pursue a career in robotics if you want. Okay, but as right now in most cases you need to have a programming language skills, and the world is switching towards the automation and control. So it is good to learn these things from the early stage, so that you can basically contribute to the society in a better way. All right, so this was basically the end of the 3-day workshop. I hope you all enjoyed this, and I enjoyed a lot discussing this with you all guys. Okay, so let me just recall what we discussed in this 3 days workshop. We started with the definition of robotics, what robotics means, how do we define robots. Okay, and then we saw what are the basic components which we require to build any robot in general. All right, and then we saw then we discussed about those components in details, like what are sensors, what are the different kinds of microcontrollers, why do we need Arduino in microcontrollers, why Arduinos are used most widely nowadays, and what are the different outputs from like LEDs, motors, actuators, and stuff. And in the day one, in the last of the day one workshop, we saw how we can basically control a LED by programming Arduino, right? And in the day two, we started with the introduction to of sensors in details, like what are the different types of sensors, like there are some analog, there are some digital sensors. And then we saw how we can basically extract the data from digital sensors or analog sensors, right? And then we saw how we can basically build our first robot, which the working principle of that robot should be that it should follow any object in front of it. Okay, which we basically programmed on this robotic kit. All right, so we programmed this robot using the sensors of the IR, and we programmed the Arduino, and we saw the live demonstration also. Okay, and then today we saw first of all how do we basically make how can we basically make a remote controlled robot, and not just by controlling it using the switch. But let's say if we do not even want to control it using this switch, but we should be able to control it just by the gesture also. Okay, so we saw what are the basic components we need to build a remote controlled robot, and how we can make our own remote controlled robot. Okay, and we saw the live demonstration of that robot, and then we saw what if any robot or any machine in general falls down from a table. So to figure out that problem, to solve that problem, we basically designed and we basically programmed this particular robot, the robot which we programmed yesterday also, this robot as a cliff avoidance or edge avoidance, which means that whenever it will detect any cliff or edge, it is going to first of all stop, it is going to go backward, and then it will take a left or right direction. Okay, and then at last, since we had some time left, okay, so we saw how we can basically program. We basically just saw the live demonstration how we can basically program this kit which I have over here. Let me just show you this. Okay, this kit, and how we can basically control this using a Bluetooth app. Okay, and so this is it, and this is how you can also learn all these things. And if anyone wants any kit which we have shown, and there are several other kits also available on our website. So I will write down in the comment section also. You can just go down to the www.curryrobotics.com, and there you will find lots of courses and lots of kits so that you can basically learn about robots and stuff. So now let me just share the feedback form so that you can please do fill that, and you will get your certificate in 1 or 2 days. By the end of Monday, I hope you will definitely get your certificate for this 3-day workshop. Okay. And if you guys have any question, any problems in robotics or with any of your project, so feel free to discuss with me. All right. So I hope you will learn this robotics in much more details, and then we all can contribute to the society in more innovation, in the more innovative way. Okay. Okay, so if anyone, as you guys must have observed, that this is basically the introductory level of robotics. If you guys want to understand or learn more about robotics in details, so you can enroll in our courses, and we can basically, if you are a school student, so we teach robotics from like this scratch. Okay, like from what basically LED is, what how can we control a buzzer or switch, and not just on the terms of programming but also in terms of electronics and hardware domains also. Okay, so if you want to learn these robotics in much more details, okay, in details, so you can join for the courses which we have on our website. You can get that on our website link, and I will share with you guys on over here. Let me just write down this in the comment chat section, and there you will also find the links of all of our social media accounts, and we will also upload this kit this sorry we will also upload this workshop video, okay, on our YouTube channel also, so you guys can check this out over there. Okay, so if you guys have any ideas, feel free to ask. All right, and so this was it for this 3-day workshop. I've enjoyed a lot to discuss the discuss my expertise and discuss all these robotics terms and all these robots, and I hope you all have enjoyed. All right. Okay. So take care. Thank you. Bye. And if you guys want to learn more in details, so feel free to check out our website link. All right. Okay. Thank you.